Hello, I'm Erin Gibbons, and I'm here to talk to you today about coping with a heating planet. I started this work as part of the Climate Justice Institute in fall 2021 that was led and facilitated by Heather Price and Sonia Doucette. And some of this work was also created by Heidi Overman and several other colleagues in the Climate Justice Institute. With this video, I hope to set the stage for climate justice topics and prompt you to think about your own position relative to the changes that we can already observe. By becoming more engaged as citizens, we can support each other to create the collective action necessary to solve our biggest, most tangled problems. Being engaged with our community also helps us maintain hope, despite what can feel pretty scary. We need to work with other people who are making a difference and recognize that our individual efforts work within the greater movement, which is led by many smart, dedicated experts. So where are we in this era of fossil-fueled climate? How do we cope with a heating planet? Let's take a look at these newspaper dates. We've known for a long time that the planet is warming as a result of fossil fuel combustion. Here's an article from 1912, Coal Consumption Affecting Climate. And another one from 1952, It'll Be Warmer and Drier. Evidence was gathered by fossil fuel companies around 1980. They knew that burning coal, oil, and gas was causing heating, and that it was going to impact societies on a global scale. I created this presentation in fall 2021, and since that time, the news about climate disasters has already increased a lot. The summer of 2023 was the hottest on record globally. In addition to the course outcomes, this assignment has some outcomes relating to your awareness of what you know, of what you're willing to do, what you know how to do, and what things you care about. From today's work, I want you to understand the problems arising from rapid global heating, as well as how you fit in as someone who experiences it, and someone with a clear role and ability to contribute to solutions. In other words, where is your power and what do you care about? Understanding the social impacts of recent heat waves teaches us that we can take action to keep our neighbors safe, to keep ourselves safe, and to build a sense of community reliance and resilience. In terms of chemistry, we consider energy, such as the heat flow during phase changes and specifically evaporation. I'd like you to be able to find data, to verify data, to recognize correlations and understand the social and legal aspects that come into play, to understand how to support claims or evaluate information that you're given, analyze the data, vet your sources, be able to understand information in a scientific way so you can make informed choices relating to your own safety, your own consumer habits, and activism. Be an informed voter and understand how to support equitable climate resilience. Be willing to have conversations and share the information that you have learned with family, friends, and community members. In this assignment, you'll practice your science communication. Your work might look something like this. You'll pick your own adventure. There will be many options for assignments, and you can pick what you'd like to focus on. I'd like you to address at least 2 outcomes from different areas and the chemistry outcome. So for chemistry, you'll answer a question related to evaporative cooling and apply your understanding to different situations to help cool down someone in heat distress. Then you'll pick another outcome from the civic or justice side, so this might be your collection. Develop awareness about the dangers of excessive heat and resources for coping with it, and develop understanding of who is most vulnerable to excessive heat and how to mitigate those inequities. The class assignment will clarify, but as we move through these slides, be thinking about what you'd like to know more about and which subset of these outcomes you want to focus on. Often there are resources in the slides you can follow up on to craft your forum post. So let's get started by looking at NASA's data. The temperature anomaly compared to a baseline of the 20th century average global temperature, which is the blue line there, the 0. This is showing that 19 out of the top 20 hottest years recorded occurred between 2000 and 2020. So very recently. As I record this video, we just experienced several days in July 2023, which set the new record for the hottest days ever recorded. More recent data can be found at the link on the slide, where you can generate your own graph of NASA data. As you see here, 1976 was the last time that the average annual temperature was below the 20th century average. That means if you were born after that time, you have never lived in a world that had the average temperature of the 20th century. It has always been warmer than that average in your entire lifetime. Who do you know that experienced average 20th century weather? To read the graph, let's take a look at the axes. This is going all the way back to 1880, and the last year of data here was 2020. Do you think the 20th century average would be similar to the 19th century average? Just looking at 1880 to 1900. Looks like all of those years were below the 20th century average. Right, here's the 20th century average, the blue line, and these seem to be scattered around a lower value. So what does the temperature anomaly mean? What is that? Why is it 0? What does it mean that it goes up to 1 here? That would be something to think about. What are we really looking at? For those of us in Seattle in June 2021, we saw the number of days over 90 degrees in June had doubled since record keeping began. We had record sequential days over 108 degrees, and mussels were literally baking open on the rocks. This person has placed aluminum foil over their windows for insulation to mitigate the effects of excessive heat, to block the sun from coming in and heating up the inside. The extreme heat is linked to lower cognitive performance in students when they are working in warm classrooms without air conditioning. CBS News reported in September 2023 that researchers at Worcester Polytechnic Institute found that at 80 degrees, reasoning performance dropped by up to 11%. And let's take a look at the map here in red. This is the heat map. Hotter is dark red, cooler is a lighter red, and the income map in green, where the dark green is the higher income and the light green is the lower income. Here's the link below. What do you notice? What are the white areas? What's the dark red right here? That is the Duwamish waterway. Compare that to the income in green. That's pretty low income area. Versus over here, Laurelhurst is a very high income, and that's a bit lighter. And same out here. Magnolia. These look like they almost overlay each other. In 2021, 1 in 3 Americans experienced a climate disaster. A third of us. These have been both hotter and drier and wetter, depending on where you live. Summer 2021 included massive flooding, heat waves, wildfire, and smoke. This was a photo from the town of Paradise before and then during the fire. And we've seen global increases in heat waves and flooding since that time, costing more and more for people and for the economy. In 2021, there was Hurricane Ida, which spanned several states from Louisiana to New York, flooded them all. And the top 20 largest California wildfires up until 2021. The first 3 in black and gray took place between 1932 and 1999. Then, in the first 20 years of this century, we had 8 of the largest wildfires, and they're getting bigger. These slices are skinnier, and then here the bigger slices are the size of the fire. This is the hugest fire by far to date. California had 5 of the largest wildfires in 2020 and then 3 of the biggest wildfires in 2021. That's a pretty rapid change, wouldn't you say? Did you know that it had changed that fast? Does your family know? That might be worth talking about, just sharing that information, having a conversation. We see that global climate change directly impacts our health and survival. It's in the news a lot now. In this example, a California family was found dead on a trail that they knew well. They went hiking with their daughter to a river and decided to hike out at midday. They had carried water with them, but were caught by surprise at how the excess heat affected them, and they were found dead on the trail. That's pretty startling, to go for a hike with your family and die. All of you die from excessive heat. And a woman in Seattle died in her home. Her neighbors were quite shocked, but she was elderly, and elderly people are more vulnerable to excess heat. And you can watch that news clip here at this link. So that heat dome event in 2021 is the deadliest weather-related event in Washington history, with 159 deaths. The previous record was held by an avalanche in 1910. We know why this is happening. We know what the causes are and what we can do to improve the situation. We know that carbon dioxide emissions, mainly from transportation, cause the heating that is giving us these extreme weather-related events. There are other greenhouse gases as well. Methane, or natural gas in particular, is an important one to talk about, but I'll leave that for another talk. So individually, you can check on your neighbors, help them know how to cool down and keep cool during heat waves, and you can research your personal choices, and you can be informed when you vote. So we know that extreme heat is tied to human-caused climate change. This is an area some of you might like to investigate further. In the graph here, we can see the observed temperature anomaly is the black line. The human drivers are in red, and the natural drivers are in blue. The natural heat cycles are proceeding along as they have, and the human-driven emissions, that would be the carbon dioxide and methane in particular, those started going up rapidly around 1960. The sum of all the drivers together is the orange line, and the observed heating tracks that pretty closely, except in the most recent years, where the observed heat goes up dramatically more than the sum of those driving forces. We know it's humans causing this, which in one sense is hopeful, because we can make changes. So which populations are most vulnerable to excess heat? Older people are very vulnerable to extreme heat. People without appropriate housing, farm workers, and others who work in the outdoor setting, those who can't afford to stay home during extreme heat events, those people are vulnerable to excessive heat and heat-related illness. Access to air conditioning can be a lifesaver. There was a study in Portland that showed that of the 54 people who died from the 2021 heat dome event, none had central air conditioning. Air conditioning can save people's lives, but not everybody can stay home in the air conditioning or afford to run the air conditioner. And remember that using air conditioning is one of the biggest contributors to the greenhouse gases and human-generated climate change, so it's not an ideal solution. Here we're looking at heat and income maps again, and in the link, there's an interactive section where you can generate your own city to compare. We know there's an equity problem from the relationship between heat and income within cities. In Oakland, up here, in this cooler section, close to the Berkeley Hills, this is a high-income area. And right down here in downtown Oakland, where there's a huge heat island, it's a low-income area. Los Angeles shows the same kind of inverse relationship. You could overlay these and they would completely fill each other out. So we know this is related, and we'll look at why in just a sec. But let's talk about action. What can you do when it's dangerously hot? Check in on your neighbors. If you know someone who lives alone or who's older, check in on them when the weather is excessively hot. If they don't have air conditioning, maybe take them to a mall or a library so they can get cooled off in the hot part of the day. You can also help them adjust their home to stay cooler by closing blinds and windows and opening windows at night if it cools off. I rotate a fan in my window to blow out in the late afternoon and in during the cool morning. So think about your own home. How can you adjust your window coverings or your fans or open and close windows if nights are cool to make sure that your home stays as cool as possible? And if you observe signs of heat stress, help someone get cooled off immediately, for example with a sponge and a fan. It's important to get their bodies cooler for at least a few hours, which you can do by visiting a place with air conditioning, especially if it's hot at night. On the community level, cities open cooling centers, and you can find out where those are and share that information with neighbors in case they have not thought about going to a cooling center. So let's normalize helping each other out and discussing options when hot days are predicted. If someone can't afford the utility bills to run their air conditioner, they can access assistance programs as well. And there's some information in this link here for Seattle region. So what are some of the things you can directly do to help the people around you if you find someone in acute heat distress? Let's connect back to the energy of phase changes and heat and how heat flows. So how does sweating work and why does a fan feel cool? What does the ambient humidity have to do with the effectiveness of sweating as a heat loss mechanism? Is it easier to cool the body down in dry conditions or humid conditions? And why do fans work as an effective cooling strategy? These are all choices you can comment on when you make your post to the forum this week. And finally, moving into some opportunities for civic engagement, you might be interested to learn about the connection between heat islands and income, which is tree coverage. Here we can compare the surface temperature map with tree canopy in Seattle. Those are the cool areas on the coast, and they correspond to the greener areas. And they have a lot of trees in those areas. So again, see here, the greener areas correspond to the cooler parts of the map. The red heat islands correspond to the gray, so that's pavement and concrete, not as many trees. The lack of tree cover can make a neighborhood hotter. The cement will absorb the heat and hold it and then release it slowly. Trees provide shade and retain moisture, so they really help cool neighborhoods significantly. Currently, our local politics point to saving trees as potentially being in conflict or an obstacle to increasing low-income housing because of the challenge of developing higher density housing while still maintaining the tree coverage. But it seems to me that if we want to have both of those things, that is just equitable. People who live in low-income housing should also have access to tree canopy and all the benefits that trees offer. The tree canopy maps, in many cases, map directly onto the race and ethnicity of the city as well. So there is a connection to the justice piece. The low-income areas are likely to be hotter than wealthier counterparts, and usually they're communities of color. That's another area where you can take direct personal action. You can get involved in your community and make a significant difference. In 2023, community action prompted a developer to redesign a housing project in order to preserve a large tree after the publicity brought the issue into the public eye. Those mature trees give a lot of shade compared to new trees that would be planted around the development. And in Shoreline in 2022, there was a community outreach to save some big trees along a roadway. It was a stand of mature trees, and they wanted to widen the sidewalk, which seems like a great idea. Because of the community outcry, they ended up spending a bit more money on the project and took more time to redesign it. They sourced the concrete locally, which actually was a greener way to do construction, as it ended up saving them some costs in terms of the fuel to ship concrete to our area. They redesigned the sidewalk so the cement piece was a little bit narrower, and they used wood supports to hold up the cement instead of cutting through the tree roots. They were able to save the whole stand of trees along that street and still build the sidewalk. But it did take community participation in the review process and insisting they design something that could retain those trees. So it really does make a difference when people show up. Prioritizing tree canopy and local decision making is an area where you can make a direct impact on your local heat island effect. So read the notices around your neighborhood, participate in local events and discussions, stay informed, and vote if you can. When we act in support of the things we care about, together with our community, it helps alleviate some of the anxiety we face as we try to solve the climate crisis. And here are some references from the slide set. Thank you for your attention and for all you do to reduce fossil fuel emissions and for creating the social movement to make this shift happen. Take care and stay cool.